Metcam's unique capabilities allow it to accurately detect and localize gas leaks, differentiate between small and dangerous flammable gas clouds, and show where they're headed. In this video, we will explain how detection sensitivity is influenced by environmental conditions. To understand optical gas imaging, OGI, we need to first understand the concept of radiometric contrast as it applies to gas detection. Consider an industrial scene where different objects are at different apparent temperatures. Apparent temperature is what an infrared camera will measure when looking at an object. Apparent temperature differs from thermometric temperature. It's lower by some amount. It is typical for the lowest temperature in the scene to be close to the ambient air temperature. The radiometric contrast is the difference between air and background radiation. Consider a case where ambient air temperature is 20 degrees Celsius and background apparent temperatures are as displayed on the color scale. This picture presents the radiometric contrast in the scene. We subtract the ambient air temperature, 20 degrees Celsius, from that of the background. We see contrast values in the range 0 to 14 degrees Celsius. When gas leaks, it quickly reaches temperature equilibrium with the surrounding ambient air. For an optical gas imager to detect a cloud, there needs to be a radiometric contrast of at least 0.5 degrees Celsius between the air and the background. The thicker the gas cloud is, the less contrast is required for its detection. Notice that as the radiometric contrast increases, the sensitivity and probability of detection becomes higher. Radiometric contrast is constantly influenced by environmental conditions, like the time of day, seasons, fog, haze, wind, or rain. A fixed installation OGI has a sensitivity cycle determined by ambient conditions and background. Constant leaks will be detected at the high parts of the sensitivity cycle. In locations where the background has an elevated temperature, hot objects, like compressor stations, detection sensitivity is constantly high, regardless of ambient conditions. Thanks to the permanent presence of Metcam, even the smallest leak will be detected, localized, and quantified.